This is TSS Types of Solution Sets, question C21. And that's just what it's asking. It's asking for this particular system of equations, what is the type of solution that it has? I'm already skeptical of this system because it has 4 variables, but only 3 equations. Now, that doesn't mean it's necessarily non-solvable. There could be an infinite number of solutions, but it all comes down to what the reduced row echelon form looks like. That's a 2-step process. First, we'll write the augmented matrix for this. So that's going to be 1, 4, 3, -1, 5, 1, -1, 1, 2, 6, and 4, 1, 6, 5, and 9. So that's the augmented matrix. It includes the 3 by 4 coefficient matrix welded to the solution vector. Okay, now what we want to do is put this in RREF form, reduced row echelon form, which we'll use some piece of technology to do. And when we get this guy in reduced row, what we get is 1, 0, 7 fifths, 7 fifths, 0. 0, 1, 2 fifths, -3 fifths, 0, and 0, 0, 0, 0, 1. Well, the first 2 rows are all right. Those indicate that there's some relationship between x1 and x3 and 4, and x2 and x3 and 4, and that's okay. But that would mean we would need to have x3 and 4 to be free, and unfortunately the last line invalidates that. We end up with a pivot in the final column, in the solution vector, and what that does is says that 0x1 plus 0x2 plus 0x3 plus 0x4 still equals 1. And of course this system then has no solution because it's not possible for any combination of these variables to add up to 1 when they have 0 coefficients. So that means the system has no solution. Anytime you get R of n plus 1, and that's a pivot row, in other words, you get a pivot right there in n plus 1, then you've got real problems. These pivots aren't an issue at all. They don't cause problems. They sort of set us up to maybe have a variable set of solutions. But this final line is the death knell for the system. Anytime that you have a pivot column in the final column of a matrix in RF form, it guarantees there's no solution to the system. So they even have a name for this. This is called an inconsistent system, and of course it has no solutions. If we wanted to identify some other particular characteristics as a result of it being in RF, again, we end up with 3 pivot rows, so R equals 3. Even the R of n plus 1 counts for that. Of course, the number of variables is equal to 4, and this isn't always bad news. It just means we're either going to get no solution or many solutions. In this case, the location of our 3 pivots is 1, 2, and 5, and with n equal 4, having d equal 5 is a death knell for the whole thing. So 1, 2, 5, and that's a problem right there. You can't have a d greater than n. And in our f's, this is basically the columns that don't have any pivots are 3 and 4. And again, you should always have, F should always contain n plus 1. And if it doesn't, then you've got big problems here.